Righty, in the last video we learned about binomial distributions. In this video we're looking at the mean and standard deviation for these distributions, and there are literally just formulas for them. So this is the situation from the last video. It was the multiple choice test and you were guessing C each time. So just as a little reminder, X was the number that we had correct, and X was distributed binomially 7 1/4. So 7 really particularly is our n value. 1/4 was our p value. That's the probability of success in one trial. And this also needs let X be the number of correct answers out of 7. Okay, so we can apply these formulas directly. Now, I'd encourage you to guess, literally just with your intuition. How many answers would you expect to get right? Quarter chance, there's 7 questions. How many would you expect? And that is the expected value, or the mean. Now, I'm hoping that intuition-wise, you would think maybe it's 1/4 of 7, and that would be exactly right. So 7 times 1/4, and it is whatever that gives us. 7 times 1/4. I'm going to guess 1.75, but let's check. Good. So you get about 1.75 questions right on average. Okay, the standard deviation is root NP 1 take P. So standard deviation is root NP 1 take P. Now this is root of. Now there are 7 questions. P is 1/4 and 1 take P is 3/4. And we can just literally work that out. So if we put that into the calculator, 7 times 1/4 times 3/4, you're going to get 21 over 16, or 1.3125. And when we square root that, we'll see what we get. It is 1.15. That's the standard deviation. And the variance was what I got before I square rooted it, 1.3125. Okay. Fun fact. You can actually use normal distributions to model binomial distributions. So we won't do it in this video, but we've got a mean and a standard deviation. So our binomial distribution sort of looks like this. And we could work out probabilities by using normal distribution approximations. And historically, that's actually how they were done, because binomials take a long time to work out, especially if you're doing binomial CDF. Now, I do say you can use normals to approximate these, but probably not in this case, because 7 is quite a small number, so this distribution is still quite bumpy. Not to mention with the probability of 1/4, this distribution is not really symmetric. It's more like really big there and sort of goes out like that. But anyway, normals can sometimes be used. Okay, check this gives the same answer from if we did the table, and same standard general formula for PDFs. So I'm not going to do the formula by hand, but if you did want the mean, you could do 0 times 1.33 plus 1 times 0.311 plus 2 times, and keep going on there. We are not going to do that. This is the table that we got from the last video, by the way. What I will do is I'll enter this as list 1 and list 2 on the calculator, and we'll see if it gives us the same mean and standard deviation. All right, so I've just gone and entered all that data in there, and we're going to go calc, make sure we got a frequency list on list 2, and we're going to go 1 var. So 1.75 was the mean, standard deviation was 1.14. Obviously, the method up the top is a lot quicker, and that's the method you will be using to get this.